Hi, hello everyone. Welcome to my YouTube channel, My Intuition. I'm Dr. Prasad. Uh, this is actually not a class as such. I'm just sharing these notes, availability of these notes. Those who are interested can get it purchased from me. It's around 33 pages notes. You can contact me 797-505-4865. Many have asked me of this, that's why I'm kept it open. Class I will continue later on I'll explain if at all is needed, but my notes itself is more than sufficient to understand the concept. So this is part 2 of module 1, computer science, that for chemistry for computer science stream. Computer science stream means it covers computer science and engineering, information science and engineering, artificial intelligence and machine learning, artificial intelligence, data science, computer science and design, computer science business system, and any AI based courses, any CI based courses. They have this particular subject in first semester as well as second semester when they comes to chemistry cycle. Okay, so part one already completed and the notes I am already circulating. Many have purchased it. Part two I kept it open because I am working on some other topic. So this topic I will cover later. This is on energy systems, part two. Okay, so I am providing the possible level questions, level 3, level 4, level 5 questions, level 6 questions are more difficult. It is something creative that they have to do project work on that. So up to level 5 we can ask questions. So based on the introduction energy system, this particular questions are asked and their answers you can find out from this, from introduction, different energy system like renewable energy sources, non renewable energy sources, then impact of energy system on environment and society, like environmental impact, societal impact, the feasibility of transitioning to renewable energy sources, what are the feasible technological feasibility of changing from the old non-renewable energy source to renewable energy sources, what are the possibilities and what are the problems that we may face, that covered economic feasibility, environmental feasibility, societal feasibility, all are covered in that. And what are the approaches to design the renewable energy system for rural community, like by how to assess, by assessing the energy demand, identifying the resource availability, determining system designs, the economic feasibility evaluating, then creating a plan. Okay, so based on that you can have students can take some of the seminar topic also, or they can continue their work on this renewable energy sources, fossil fuel based energy systems. Okay, so these are some of the seminar topics that I kept it open. So then second point of that particular part 2 module 1 part 2, that is introduction to batteries. Only level 4 questions I kept here because level 4 questions are more likely to be asked. Okay, so in introduction, what are battery we have to already know. So just I kept, I didn't put the image representing anode, cathode, all those things I have not represented given here because already we know the environmental impact of batteries. What are the impact of batteries, what are the recent problems that we are facing, that is on production, the use of battery, the disposal, mainly the disposal we have, because lead containing battery, mercury containing batteries, they are creating lot of issues. Okay, so the choice of battery for a specific application, we have to consider the energy density, we have to consider the cost of the battery, the cycle life, how long we can reuse it. That are the main criteria to select a battery for a specific application. The commercial availability of batteries, we have right now, we have lithium ion batteries in the market, lead acid batteries are there, nickel cadmium batteries are there, nickel metal hydride batteries are there, flow batteries are there, sodium sulfur batteries are also there. Okay, so next topic, that is mainly about lithium ion batteries, because nowadays most of the market it is taken up by lithium batteries due to the introduction of the electronic vehicles, EV. uh, every EV now they are using lithium ion batteries, then try to change it to the sodium ion batteries. Okay, so lithium ion batteries, again level 4 questions only I kept. Most of the possible questions you can expect as level 4 questions. So all the possible level 4 questions I kept here. Answer you can find out from these notes, study material. Okay, so introduction. What are the different names? How we call the lithium ion batteries as Li ion battery, lithium polymer batteries, LIBs, rechargeable lithium batteries. These are different names that we use for lithium ion batteries. Construction of lithium ion battery in general, if you discuss, it has got a cathode, the material which are used as cathode mentioned here. Anode, the material used as anode also mentioned with the diagram. Okay, so you can see the cathode containing lithium cobalt oxide, and anode side it is made up of a graphite layer coated on copper. A separator is there, electrolyte is there, and it has got a charging, discharging, the movement of electrons represent during charging. Electrons moves from cathode side to anode side. Then the lithium ion will move from cathode side to anode side. That means from lithium cobalt oxide to the graphite side, the lithium ion moves during discharge. Discharge means when it gives the work, when we get the work. Recharge means when charge means when we are charging the battery. When you are charging the battery, the lithium ion going to the graphite side, that is anode side. When it gives work, lithium ions are moving towards the cathode side, and we are getting the electricity required, power output from that. It has got a separator, which are the material used as a proper separator, like polyethylene, polypropylene, which are the electrolyte used, like lithium hexafluorophosphate, and which are the current collectors, and the casing, which material used to prepare the case, and which are the collectors, the electrodes, means further connections made up of which materials are used, so that improved efficiency is expected. Working of lithium ion battery, working, it can be during charging. Charging means when we charge the battery. Okay, we know most of the, even nowadays, most of the mobile phones are also lithium ion battery. Therefore they say that once we purchase a mobile, we have to charge it first for 8 hours, so that the anode side will be fully packed, so that it will start giving the functioning work. Okay, so initially we need to charge it properly, then recharging, again charging, recharging and charging, it can be done many times, that we call as a life cycle, the cycle life. Okay, so charging, during charging, explained during charging, the lithium ions are moving from cathode side to anode. In the previous figure I represented cathode on left side, anode on right side, don't get confused. Okay, so here, yeah, anode on left side, cathode on right side, it just mentioned. Okay, so during charging, the lithium ions move from cathode side to the anode side, because we are giving electron supply to the anode side. Therefore positive charged lithium ions will move to the anode side, which is graphite, mainly graphite layer is there. On that, it will go intercalate, it will go and sit in between the gap of the graphite layers. From the lithium cobalt oxide layer, it goes, that is cathode layer to anode layer. Rusting means once we are not charging or discharging, that time the lithium ions will stay calm, it will not move. But during discharging, when we are getting the required work, the lithium ions will start move from cathode side, anode side to cathode, that is from the graphite layer to the lithium cobalt oxide side, that is discharging. Okay, so the overall process, it is reversible, which allows the battery to be recharged and used again. Okay, now materials used in lithium ion batteries, the cathode materials, we can use lithium cobalt oxide, we can use lithium manganese oxide, we can use lithium nickel cobalt aluminum oxide, or lithium nickel manganese cobalt oxide. These materials are already studied and it is used. Anode materials, mainly it is graphite, and even silicon is also used, uh, because it can also store lithium ion, then but it has got some issues, so it will crack easily. Therefore graphite is the best solution. Even lithium titanate, it's also used, but it's a low capacity anode. Only fast charging applications it is used, not the regular applications. Okay, then third one, electrolyte. Electrolyte, two types are there: lithium salt in organic solvent, as well as solid electrolyte. So lithium salt organic solvent, the examples also mentioned. Solid electrolytes, like lithium phosphorus oxynitride, lithium sulfide, lithium garnite, polymer electrolyte. separator polyethylene, PE, polypropylene, polyvinylene, vinylidene fluoride, cellulose, ceramic coated polymer separators are there. Anodic reactions of lithium plus going on. Anodic reactions of lithium-ion batteries during the discharging and recharging, it is given the graphite reaction, graphite side reaction, that is anodic reaction, in which lithium ions accept the electrons and convert into lithium are getting intercalated to the that of a graphite layer. Um, then uh, during the discharging, the reverse reaction happens from the lithium from the graphite layer. The lithium ions will start move to the other opposite side. That is with if it is a graphite anode. But if it is a silicon anode, then Li for Si is the material which is present there. That is Si will go and stick on the silicon. Lithium ion will go sit on the silicon layer, and the reaction is similar to that of a previous one. Even lithium titanate anode can also be used. That reaction also given here. Balanced reaction is given. Cathodic reactions, if you mention cathodic reactions with lithium cobalt oxide, lithium manganese oxide, or if you use lithium nickel cobalt aluminum oxide, all these cases are also explained. So you can choose anyone as per the study material provided by your teacher. Okay, so lithium nickel manganese oxide also mentioned here. Suitability of lithium ion batteries for various applications. Why we use lithium ion and why we use that lithium ion battery for a different a particular application, that is mentioned. For portable electronics, what type of lithium ion batteries used, that we already seen, that is smartphones, laptops, tablets. Electric vehicles, we use lithium ion batteries. Then because it has got high energy density, cycle life, and safety compared to other batteries. Renewable energy systems, we use lithium ion battery. Medical applications, aerospace applications. Now the different types of lithium ion battery and the applications with examples, if you mention, we might have used, we might have seen smartphones, laptops, we use example like iPhone, Apple iPhone, or a MacBook, we use lithium cobalt oxide material. In case of electric vehicles, like the Tesla Model S or Powerwall, all these systems, we use lithium ion phosphate battery. Then in case of Chevrolet Volt, not Chevrolet Volt, Chevrolet, it pronounced as Chevrolet. Chevrolet Volt, we use manganese, lithium manganese oxide batteries. Nickel, cobalt, aluminum, like that. All the examples were and are used, and that mean Samsung Galaxy, Nissan Leaf, the portray electric buses. All these cases, which type of battery it is used, that is mentioned here. So it's a very useful information when you go to such type of electronics based industries. If you go, you can get it used. You will get help of this information which I provided. Advantages: high energy, low density, cycle life, fast charging. Limitations are also given. Okay, now environmental concerns. Then some of the seminar topics based on that. Sodium ion batteries, that is a recent development. Sodium ion batteries replacing the lithium ion, because lithium ion is a very rare metal. Sodium, it is completely available. If you go to ocean, take sodium and come. So that much sodium is available. Only extracting and using it, that you only got to think. So possible questions up to level 5 are given here. Introduction part mentioned why the need, why the research is going on. As such, sodium ion batteries are not there in market because it has got so many limitations. But still research is going on that and trying to replace wherever possible. The components, which are anode materials, which are the cathode materials, and the electrolyte, separator, current collector, everything I collected, and information collected and kept in my this study material. Okay, here of image representing the sodium ion battery, the material, positive electrode, negative electrode. What are the electrode material used? It is already mentioned here. Only here the image it helps. Now working of sodium ion batteries, the anodic reactions during discharging, during recharging, Then cathodic reactions, that is again during discharging, okay, you can bold it, during discharging, during recharging, okay. Then the suitability of sodium ion batteries, suitably how it is suitable for different applications: grid energy storage, stationary energy storage, electric vehicle, off-grid power system, portable electronics, everything is mentioned here in this part. Okay, now types: sodium ion batteries with sodium ion intercalation cathode. Application: if it is grid energy storage, then example is given. If it is portable electronics, then example is given. With the conversion type cathode, again that is electric vehicle, what type of sodium ion batteries can be used? For a stationary energy storage, what type of sodium ion batteries can be used? If it is sodium sulfur batteries, then again application: grid energy storage as well as off-grid power system, what type of materials are used? Advantages: it is very abundant and cost effectiveness. Safety measures are good. Environmental impact is very less. Scalability: we can produce certain amount of sodium. The chemistry of sodium is similar to that of lithium, but it has got limitation like low density, low energy density, limited cycle life, slower charge and discharge rates. It will not get charged immediately, and it won't give discharge also easily. Okay. Then limited commercial availability, material compatibility, and electrolyte challenges. Limited research and development in this field, which are all made all these possible drawbacks. Some of the seminar topic based on sodium ion batteries also mentioned here. Then the last topic, quantum dot sensitized solar cells. You know already what is solar cell. Sensitized solar cells, another topic. In that, quantum dots are used. So answer it is given. Introduction part, it is mentioned what are QDSSCS, what are quantum dots, that is mentioned, which are the materials which used in such type of solar cells, that is mentioned: cadmium, lead sulfide, copper indium sulfide, zinc oxide, and other semiconducting materials are also mentioned here. Now in QDSSCS, that is quantum sensitized solar cells, the components, it consists of the quantum dot, it consists of a sensitizing die. Example is also given, no need to by heart that one, only just you can check that it is the, we need a sensitizing die. Photo anode required, electrolyte required, electrolyte, liquid electrolyte, solid electrolyte, quantum dot, solid electrolyte. Then counter electrode, transparent conducting substrate, sealing material, external circuit required, everything required for that, also mentioned here. Then working principle, working of QDSSS, absorption of solar radiation. It has got photoelectric electrode, excitation of electron takes place, charge separation, electron injection, electron transport, current generation, Hall transfer, everything happens. Then charge separation, overall performance. Properties of quantum dot solar cells. Why? What are the main properties? Like it has got a tunable optical property, high absorption coefficient, multiple excitation generation, large surface area, like that. Then applications of quantum dot side solar cells: photovoltaic applications, sensitized photocatalysts, light emitting devices, biological imaging, sensing and detection. These are the image. So this is my class study material on the part 2 of module 1 for the first year computer science and engineering stream students, CS stream students. Not only computer science and engineering, the stream. There is more than 16 courses are there under computer science and engineering under VTU. All can make use of this study materials. Teachers can use it as a reference to compare with their study material. So if you want this study material PDF note, you need to pay me 10 rupees. It's around 33 pages. So how to pay and how to get that study material, I'll be transferring to your WhatsApp number. You need to WhatsApp me on my number 797-505-4865. So thank you very much for watching this. Please bring this to notice of the first year students of computer science stream, so they can get it purchased from me for 10 rupees only. I took that much effort to prepare this one, so they can purchase it from me. Thank you very much.